In this video, we are going to use determinants to determine if three given points are collinear. Now, the test for collinear points, we're going to take our 3 points and we are going to put them into a 3 by 3 determinant. You'll notice here that I've just listed out my 3 points. We're going to use one down the column to the rightmost column. And if that determinant value is equal to 0, those points are collinear. If that is any other value, the points are not collinear. So it's just a matter of remembering how to do a 3 by 3 determinant. So let's walk through that process. So we have these 3 points. We want to know whether or not they are collinear. So we can set up a determinant. You'll notice I've just taken our 3 points, -2, 6, -4, 3, and 2, 10, and put them into our first two columns. Now, there are multiple ways to find the determinant of a 3 by 3. Oftentimes, we use our top row to set up our minors. There's a diagonal method. There's lots of different methods to do it. Since these ones are so nice in this column, I decided to expand it by this column here. So remember, your first one, you're going to multiply by its minor. Then we are going to subtract the middle one here times its minor, and then we are going to add this one times its minor. So let's expand it. Let's talk through that one more time. So for one here, if we were to cross out the row and column that it's contained in, we would be left with these 4 elements here. So that's where that came from. So it's going to be that number times that. Then we're going to subtract the middle one here. So if we cross out that row and column, we're left with this -2, 6, 2, 10. But remember to subtract that one. And then we're going to add the bottom one. If we cross out its row and column, we're left with this minor right here, -2, 6, -4, 3. So that's how we've done that. Now remember, for a 2 by 2 matrix, in order to find its determinant value, we're going to cross multiply. We're going to start in our upper left corner. We're going to multiply. We're going to subtract the value of the multiplication of this diagonal down here. So I've expanded all that out, but let's just talk that through what we would do. Okay, so it would be 1 times the quantity of -4 times 10 minus 2 times 3. -1 times the quantity of -2 times 10 minus 2 times 6. +1 times the quantity of -2 times 3 minus -4 times 6. Now, you can write that all out, or you could do these multiplications as you go. So like our -4 times 10, -40 minus 6, -20 minus 12, -6 plus 24, because the two negatives do, you're subtracting a negative, you're going to get a positive value here. And then order of operations. Let's get each one of these to be a singular value since we can. I made that -46, -32, +18. And then when we do the multiplications, we get -46 plus 32 plus 18, which is a value of 4. We did not get the value of 0 that we were hoping for. They are not collinear. So we can look at a graph. You can see here that you can pick any 2 points, connect them with, well, I've connected the -2, 6 and -4, 3, but this 2, 10 is just not lining up with that. So a graph should tell you, oh, they didn't line up. They're close, but they didn't line up. That's how we check for collinear points using a determinant. Let's do one more. Now you'll notice I have the same points again, but I wanted to show you one that did work, so you kind of know what the answer is going to be. But if that was, instead of 210, if it was 212, watch what happens. Same idea. I'm going to use the columns. I'm going to expand it. So same thing that we did here. We're going to do the expansion. We're going to get those values. This time, when you do all that work, you get 0. So if we were to look at the picture of those points, Not only do we connect -4 and -2, -4, 3 and -2, 6, but 2, 12, it lines up perfectly. All 3 points are collinear. So that is a little bit about how you can use a determinant to check if 3 points are collinear. So thank you so much for watching. You have a good day.